Alright, section 2, we're still with right triangles, but now we're going to be finding unknown angles given two sides of a triangle. Nice part about this section is it is kind of review in some respects because you still set up your equations the exact same way using the same trig ratios and so on. But want to first of all say, well, before we always had an angle and we were trying to find a side. Technically we had an angle on one or more sides, but if you're trying to given an angle, you're going to find an unknown side, you're going to use one of three things. You're either going to use your sine, you're going to use cosine, or you're going to use tangent. And now we're going to have two or more sides. We're going to be working backwards to find an angle. So really we need to kind of undo what we were doing there. That's been a theme in Algebra 2 this year, that we're talking about inverses and how inverses undo something. If you think back to when we used Euler's notation and we had f of x, I'll write it over here. So we had f of x in some equation. Then we found the equation for the inverse. Well, we wrote that with a little -1 up there and called that f inverse of x instead of f of x. Well, we do the same exact thing here. Instead of sine, we'll do the inverse of sine. Or instead of cosine, we'll do inverse cosine. Or instead of tangent, we do inverse tangent. So if you look at your calculator where you have your sine key, if you do second and then your sine key, it should do the inverse sine. It will undo the sine function. And if you're unfamiliar on getting like the opposite, the adjacent, the hypotenuse, those sort of things, go back and check out the 10.1 notes. But I'm going to say we're trying to find this angle here. So my problem then is saying find theta given this triangle. And when we have that, well, what side is which depends somewhat on theta. The hypotenuse will always be this one, the longest side that's across from the right angle. But now we have two legs. My opposite leg has to be the 7. Because the opposite leg then is opposite the angle that we're talking about. The adjacent leg is going to be the leg that's adjacent to or that's touching my angle. So if I go here, like I said in the last section, half the battle sometimes is just figuring out which one do you use. Use sine, cosine, or tangent. So until you get good, I'd encourage you to start out by writing out SOHCAHTOA, or some old hippies came a-hopping through our alley. We're looking for an angle. So it could be sine, cosine, tangent of the angle, so you can underline those. Now, the two sides that we know, since this is our unknown, the s, the c, or the t, you say, well, the 7, what's the 7? That's the opposite. So we could use the sine or the tangent so far. We also know the 15, which is the adjacent. So tangent is the only one that we know two things. We know these two, and then we also have our unknown in it. So this one's going to be tangent. So tangent of theta. So we go from the TOA, or through our alley, write out our trig ratio. So tangent of theta equals, the O stands for the opposite leg, divided by the A, which is the adjacent leg. Like I said, getting here sometimes is half the battle for people. So now then we have tangent of theta. Well, we still don't know theta, so we'll just write tangent of theta. But now we have our opposite, which is 7, over our adjacent leg, which is 15. So we're here to tangent of theta equals 7 over 15. You can kind of look at it as though if you had this angle theta and you did tangent to it, you'd come up with this fraction, or that decimal if you were to punch it in. So if we're trying to find this theta, we need to undo the tangent, because tangent is what got us to the 7 over 15. So the way that you undo the tangent function is to do the inverse tangent, and if you do that you have to do it to both sides. On my left side when I do it, that just drops out, leaving me with theta, my unknown angle, equals inverse tangent of 7 over 15. So we could take then and just punch that into our calculator. So I'm going to flip over to my calculator program here, and I want to do inverse tangent, so I do second and then my tangent key. I get the little tan with a -1 for inverse tangent. Type in 7 divided by 15. Don't have to end the parentheses because it's at the end of what you're typing in, but that tells me 25.02 degrees. So theta then is 25.02 degrees. So that's really kind of it. I'm going to talk about one other thing that comes up in this section, then go back and do another example. So you could stick around for the second example, but I'd at least copy these down. Angle of elevation, angle of depression. This angle of elevation both of these are always going to be measured from the horizontal. So elevation, you can think about like elevated spirits, it's up, or an elevator takes you up. Measured up from the horizontal. So if the book's talking about what's the angle of elevation of the plane or the mountain or the building, they'll always be talking about this angle right there. Never is it measured from the vertical. Angle of depression, the same thing, that depressed people feel down, not to minimize it, but that's very, very oversimplified. But depression then is going to be down, or maybe a depression in the earth. So measured down from the horizontal. So angle of depression then would have to be this angle here, measured down from a horizontal line. Now, if you think back to geometry, in geometry class, if you have two parallel lines, and you have a line that bisects them, or crosses them, I should say, intersects them, angle of depression is going to be up here, and that's angle of elevation is going to be down here, and alternate interior angles are congruent. So your angle of depression has to equal your angle of elevation. So angle of depression equals your angle of elevation. Or you could put in your little symbols like that. And that'll be true always. So if you can find the angle of elevation, but you were supposed to find the angle of depression, find the angle of elevation, it's the same thing. On to the last example. So last example, we'll quick stick this thing in here, and I'm actually going to change this quick a sec if I can. So I just noticed this would be another tangent. We don't want another tangent. So if we take this problem here, so if you make your right triangle, and I'm going to put my theta up here at the smaller angle. So you start out by doing SOHCAHTOA. And figuring out, well, is it sine, is it cosine, is it tangent? You kind of know it's not tangent based on what I said, but you could do sine of the angle, cosine of the angle, or tangent of the angle. So we underline those three. You always underline those three. Then you say, well, what's my 7? 7 is going to be the hypotenuse because it's across from the right angle. So it looks like it's going to be sine or cosine. 2 then is a leg. It's the leg that's touching my angle, so it's the adjacent angle, which then means we're going to use the ka, or the cosine. So what the ka is saying is cosine of theta equals the adjacent divided by the hypotenuse. And now we can just go and start filling those in. So cosine of theta, all right, my adjacent leg, it's going to be 2 divided by my hypotenuse of 7. And so far we've set it up just like we did in section 1. So kind of more practice there. But now, like that last example, you could kind of look at this as though they had the angle theta, they did cosine to it and got this fraction. Well, if we're trying to get back to my angle, we need to get rid of this cosine. So we get rid of cosine by doing the inverse of cosine. But whatever you do to the left side of an equation, you have to do to the right side. So those two drop out. And you're left with theta equals inverse cosine of 2 over 7. And if you punch that into a graphing calculator, you need to make sure that it treats 2 divided by 7 like a fraction. So then I could do inverse cosine here, and 2 divided by 7, and the parentheses if you want to, because it's at the end, hit enter, and we come up with 73.4 degrees. So 73.4 degrees. If you find that you're getting totally different answers than what I'm getting, go back to your calculator and make sure that you are in radian mode. I'm sorry, make sure you're in degree mode. My mistake there. And this isn't working very well. Here we go. So make sure that you're in degree mode. If you're in radian mode, then it's giving you your answer, the angle in radians instead of degrees, which will be different. So that's all I have from section 2.